Chapter 2, Day 4. We want to look at, one of the things we're going to look at is assessing normal. So one of the things that we've learned about with our normal curve is that if the curve is normal or approximately normal, between 1 standard deviation and -1 standard deviation, we have about what percent of that data falls between? I think I heard 68. Yeah, 68%, right? Well, what if we have a situation where it's not 68%? Let's say, for example, it's 72% between there. What would that tell you about that curve? It's not normal. That's right. It's not normal. So this is a case of a non-normal curve. Now, to be perfectly honest with you, this is the first textbook that I've seen that dealt with this. Either I missed something previous to this textbook or it wasn't in there. So I think I want to go through an example in the book with you about assessing this. So on page 132, we have an IQ example. Now, so what we need to do is on page 132 is we need to put in some data. I'll put it up here for you, but it'd probably be easier if you look at it in your own book. It's this guy right here. Now, we assume that IQ scores are normally distributed, but what we want to do is we want to verify that. So if you wouldn't mind, take and put these numbers into a list for me so we can go through this together. See if I still have it in mind. Yeah, looks like I do. Sounds that we're getting pretty close. What you might do if you're waiting is go ahead and graph that in a histogram. Also, graph it in a histogram. histogram should look pretty normal. Definitely has an approximately normal look to it. And so just I'm going to sketch that. Just a simple sketch. I'm not going to really worry too much about anything other than a simple sketch. And it looks something like this. Yeah? So it certainly has, the histogram has an approximately normal look at it. They give us, in the book itself, they actually give us all of the stuff that we would need from one-bar stats. Your n, your mean, your standard deviation. Your median and your standard deviation, I'm sorry, your median and your mean are very close to one another, so that's a good indication that we're heading in the right direction. So I'm going to write those numbers down here. X bar. I'm going to round the X bar, the mean, a little bit. That's I'm going to call that 115. Okay, round it just a bit. Standard deviation, about 14.8. Now, the thing that I want to do is I want to apply this now to a normal curve. Seeing that it's Pirate Day, I gotta have a skull and crossbones at the top, right? Okay. Alright. I don't know, that's a pretty pathetic skull and crossbones. It looks more like a jack-o'-lantern on sticks. Okay. Don't criticize me. Don't criticize me. I can't handle it. Okay. So one standard deviation away from the norm would be minus 14.8, so that would put us at about 100.2. And one standard deviation above the norm would be plus 14.8, so about 129.8. So a question that we want to ask of our set of data actually is how many numbers of the set fall between 100.2 and 129.8. And then we'll take that number and we'll divide it by 60, because there are 60 bits of data. So I'm going to go back into my list here, and there's probably a more efficient way to do this, but I'm looking for numbers greater than 100.2, so I can't count 100, and I'm just going to count until I get to 130. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then I get to 130. So 30 plus 11, I've got 41 numbers, 41 digits fall between these. So 41 out of 60. And remember what percent of the data should fall between here if it's normal? 68%. And what do we get when we take the 41 and divide it by 60? We should get pretty close to 68% if it's normal. Oops. I get 68 1/3. Do you? So we're close enough there. Again, we're not expecting perfection here, but we're close. Let's go out 2 standard deviations. Just for the fun of it. If I go out 2 standard deviations in each direction, so that's going to be another 11 or 14.8. So 129.8 plus 14.8 is 144.6. And I have 85.4. Now, between these two, we should have 95% of our data. At least. So we've got, how about what falls between 85.4 and 144.6. Now, there's probably an easier way to do that than the way I did it. I'm just going to look at my high numbers and my low numbers. So I have 2 numbers that are less than 85. And if I go up, I get to the higher numbers. And I've got no numbers greater than 144. So I have 2 out of 60, which equals, I believe that is exactly 95%, isn't it? I'm sorry. I got that wrong. It's not the ones that fall outside, it's the ones that fall in between. So it should be 58 out of 60. So about 96.7%. That's what I have on that. I thought
There is a higher one.
Is there a higher one? Did I miss a number? Oh, I missed a number. Okay. I missed a number. So it would be 57 out of 60. Thanks. So there is 1 higher and 2 lower. And that is 95%, is it not? That would be 95%, 57 out of 60. Yeah. Okay. So I think it's good to see it once. I certainly have never given a test question like this in the past. I'm not going to say that there won't be a test question in the future like this, but I've never seen a stats, like an AP stats question that's anything like this, as far as, on the stats test itself. Again, not that there couldn't be, there certainly could be, but yeah, I'm probably not going to make a big deal out of going through that. But hopefully you see how that works, and you're just looking at the data that you have and see if it fits. So in this case, we definitely would say that this is approximately normal. We're close enough. We're right on the 95%. We're close enough on the 68. One other thing on this before I move on. If I graph this a little bit differently, there's another way to look at things and see if they're approximately normal, and that's through the graph. So obviously we've seen the histogram looks fairly normal, but there's another way to look at this to see if we have an approximately normal situation. This pirate needs to learn how to talk today. We're going to use just a dot plot here. So if you go all the way over to the dot plot and choose that, and then hit graph, and probably zoom 9 that, what do you notice about the pattern of the dots? They clump up. It's fairly straight line, yeah. It is a fairly straight line. There does seem to be a larger concentration in the middle, for sure, right? And less on each end. But what we're looking for is a linear pattern, or a roughly linear pattern, and it shows that that's true. So this is also roughly linear. And they clump up in the middle. That's probably a good thing too. All right. Okay. All right, let's talk about the calculator itself. We did a problem where we looked at x is greater than negative 1.66, but this is going to be TI 84 or 83 or whatever, finding areas from values. In a normal distribution. I mentioned earlier that this is not my favorite way of doing this, mainly because, I don't know, maybe the graph isn't visual, but I just feel like it's not visual. Okay, so let's look at a problem. X is greater than negative 1.66. We had that asked today in class. And we're going to assume a couple things. We're going to assume that mu is 0, our average is 0, and that the standard deviation sigma is 1. So population mean is 0 and standard deviation is 1. And here's what we're going to do. We're going to go second and the number var, or the letter, not the letter, the key vars. It's over here kind of by your arrows. We're looking for the distribution is what we're going after. So second vars, that's our distribution. And we want to choose normal CDF. It's the second one down. CDF is cumulative. You're adding up all the space. So when we do that, we bring up a menu. And unless you have one of the older calculators, the lower number, we're going to put in negative 1.66. For the upper number, we're going to put in, see, when we draw this out, I've got negative 1.66 back here somewhere, and I'm looking for the amount of area that's greater than that. But how many standard deviations out do I go before I get to 0? You never do, right? You never really do. But you approach 0 for sure. The book, in the book example, they actually used a really high number of 1,000. I don't think that's necessary, frankly, but let's play with that. So they're saying the upper number is 1,000 standard deviations away from the norm. I'm kind of surprised the calculator accepts it. It does. Mu is 0, sigma is 1, and paste. And this is how it would need to look. You would put, let's have some weird setting in here. Negative 1.66 here, comma 1,000, comma 0, comma 1 if you have one of the older machines. I don't know if anybody does in here. And it'll tell you, wait, what? Hang on. That didn't give me the right answer. Oh, I didn't change that. Sorry. So it was telling me what I thought it was. There we go. So about 95% of the data falls above it. 95.9515. That's what we found on our table earlier. But this will go even out farther than that. For the fun of it, okay, and I want to show you something on the calculator. Yeah.
So is that the value that's
More than. It is. Because you're setting the boundary, the lower boundary and the upper boundary. So that's part of what I don't like about it, is you have to keep it in your head straight when you're putting it in. Are you upper or lower? Because the table always gives you the same, where this will give you whatever you ask of it. Okay? Yeah. Do you guys know that you can copy a function? So instead of putting all that stuff in again, if you go up, at least on the newer calculators, and you can't see it on the screen, but this should be highlighted in blue. You highlight that in blue, and then hit enter or green or something like that. It'll copy it, and then you can just change the details. Let's change this 1,000 to 100. So I'm just going to go onto one of the zeros and hit delete. If you hit clear, the whole thing will go away. You'll have to copy it again. And then I'm going to hit enter and see, did my values change at all? Not at all, right? So at 100 standard deviations, that didn't change. Let's do 10 standard deviations. Did my numbers change? Not in the least, right? So when you make a ridiculously large number, it doesn't have to be all that large, right? To go out 10 standard deviations is so rare and such a small probability. Well, what do you say? Shall we change it one more time? Let's make the 10 something less than 10. What do you think? 6? Let's try 6. So I'm going to delete the 1 and change the 0 to 6. Oh, it changed it a little bit. Now I've got 2 8 down here instead of 3 8. Right? Yeah. So you don't really have to put a ridiculously large or ridiculously small number into the calculator when you're setting a boundary. 10 and negative 10 would be just fine. Okay? So what if we did a problem, let's just try this. What if I said, let's just do anything. How about if I said 0.012, I'm sorry, how about 0.12? 0.012 is too small, is less than x, is less than 2.26. What's the area there? So now I have two boundaries. So if I go back into my second vars, into my distribution, normal CDF, my lower boundary in this case is 0.12. And my upper boundary in this case would be 2.26. And we'll leave the mu and the standard, the mu and the standard deviation alone this time around. We'll paste that in. And that's going to give you the area directly. Okay? So between these two values, you have about 44% of the data. Or there's a 44% probability. If another way to think about this is this. About 0.12 would be pretty close to 0. And 2.26 is going to be over here quite a ways. If I threw a dart at this normal curve, assuming that I hit the curve every time I throw the dart, what's the probability that I hit that spot, that area? About 44%. That's what the normal CDF stuff is. Okay. About 44%. Okay. All right, one more that I want to bring up. It's the inverse norm. The inverse norm works like this. I'll ask you the question, what z-score for 90% of the 90 percentile? You know, it's Pirate Day, and one of my favorite pirates is Captain Hook. And whenever I see percentile, for whatever reason, this is what I get in my head. I don't know why. Probably crocodile percentile, something like that. Okay. So if you ever see a crocodile on my paper, you'll know that I'm just being kind of scared for Captain Hook. All right. So it's called association. I can't do association with names, but I can do association with percentile, right? Okay. Second vars. That's in our distribution again. And we want to choose inverse norm. All right, I'm going to clear this stuff out. Second vars. Inverse norm. Area, 0.9. We'll leave the mu and the standard deviation alone. Now, here's where it can get a little bit different. Left, center, or right? Well, left is going to be the less than, right? That would be your 90th percentile. Center would be your middle 90th percentile. That's going to leave 5% in each tail. Okay? And right's going to be the upper 90. And there is your z-score for the 90th percentile, 1.28. Okay. And let's double check that. Or I can double check it. If I look for 1.28 on my table here, 1.28.8997, that's as close as the table can get me to 90th percentile. Okay. So, a couple different calculator tools.